Okay, the next test we have here for evaluation of platelet function, we have your platelet adhesiveness. So when speak about the platelet adhesiveness, so this would tend to measure here the ability of the platelets to stick to your surface. Okay, yung ability of the platelet to stick, okay, or to adhere, ganun, diba? So, in vitro, it could eventually be able to stick with your glass surface, or in vivo, your platelet could able to bind with your collagen. So the method here for evaluation of your platelet adhesiveness, we have your Salzman method. So for this one, okay, you're going to collect your blood, you put that one in your EDTA, okay, then try to perform here the routine na platelet count, that become your platelet count 1. For your platelet count 2, you collect your blood, you put that one in your glass beads system. Okay, then after you put your blood on that, you try to perform again your platelet count, that become your platelet count 2. Okay, for the computation, so we have your platelet count 1 minus your platelet count 2 over platelet count 1 times 100. Okay, that become your platelet adhesiveness. Okay, normal values for that, 26 to 60%. Okay, less than 26% would signify here problem with your adhesiveness. So that will signify here your von Willebrand disease. Okay, ulit. We have here decreased na platelet adhesiveness will signify problem with your adhesion problem. So problem with your GP1B95 complex. So could be your Bernard-Solier, or you could also have your von Willebrand disease for that. Okay, the next one, we have here the clot retraction. The clot retraction is the function of your platelet, highly dependent on the ability of your blood first to clot and to retract. When speak about retract, I try to push here away from the surface. That would enable you to retract here in order for you then to release here the serum out of your whole blood. So this one is highly dependent on the platelet count and your fibrinogen concentration. So kung mababa ang platelet count, mababa ang fibrinogen concentration, it will not most likely clot and retract agad-agad. Okay, we have here the different method for your clot retraction. First, we have your castor oil. That's your Hersbeck method. So this one you see the castor oil. So just drop your castor oil in the container, like your beaker. Then you just drop your blood. Observe here for the nipple-like or the dimpling formation. Normal values for that, we have your 15 to 45 minutes. Next, we have your Stefanini. So procedure for this one, just need to collect 3 to 5 ml of the blood and then let it stand at room temperature for 1 hour, 2 hours, 16, 18, 24 hours. Okay, normally, our blood try to clot, okay, within 1 hour. Okay, after 1 hour, in complete retraction taking place for 18 to 24 hours. Okay, so pag hindi siya nag-clot agad, so there's a problem with your clot retraction. Okay, another method, we have your McFarlane. So procedure for that, you collect your blood 3 to 5 ml, or you can have your 3 ml. Just need to take note and measure the total volume of the blood you use. So kung 5 ml, okay, then you put your blood in your test tube lang. Okay, nilagyan mo ito ng spring. Incubate the water bath here for 1 hour. So after 1 hour, we are expecting nagka-clot ito. So after that one, tatanggalin mo, try to pull off your spring. That will enable you to, okay, to get here the clot in the blood. That what remains would be your serum. Then after that one, try to measure the volume of the serum. Okay, so you're going to observe also here the quality of the clot. So quality of the clot also related to ability of your blood sample here to retract. So dapat pag okay ang clot retraction, you're able to form a solid na clot. Diba? So pag solid ang clot, wala masyadong RBC fallout. Sabing fallout, may mga nagpo-fall here at the bottom. Kaya fallout. Okay, kung hindi siya ganun kaganda ang clot natin, like soft ang clot mo, so expect yung pagtanggal mo, madami magkaroon ng RBC fallout. So, solid na clot, wala masyadong fallout, madaming serum sample would give you a better na clot retraction time result. On the other hand, soft na clot, madaming RBC fallout, konting serum ang ma-yield natin, so that would signify problem with your clot retraction. Then you try to report here your clot retraction time as the percentage. So, that's the volume na serum, may measure mo over the total volume na ginamit mo times 100. That become here the percentage. Okay, normal values 44 to 67%. Decrease clot retraction or problem in clot retraction would be related to your Glanzmann thrombasthenia. That's defective na glycoprotein 2B3A receptor. Okay, another test here for evaluation of your platelet function. We have here your capillary resistance test. So this test would measure here the ability of our blood vessel primarily to withstand the presence of your pressure. Because you're applying here, like the procedure you're applying here, the pressure cuff. So kaya niya ba or hindi? If not, it will also here to your PTK formation. Okay, this one correlate here with the degree of your thrombocytopenia because again, this one could be monitored here by the number of the PTK. As parang principle niya, pag madami kang PTK, mababang platelet count, or you have problem with your vascular or your blood vessels. Okay, so procedure for this one, the method for that, we have your Rampel lead test or simply your tourniquet test. Okay, procedure for that one, you'll be applying your pressure cuff in the forearm and try to inflate that one at to 100 mercury na blood pressure for 5 minutes. After 5 minutes, release mo. Then after 10 to 15 minutes, bibilangin mo dito ang PTK. Okay, try to count here the PTK on this area lang dito. Okay, not dito kasi dito ka nag-apply ng ating pressure cuff. Here only. Okay, then based on the number of PTK, so your reporting would be, okay, if you have 0 to 10, that's 1 plus, 11 to 20, that's 2 plus, 21 to 50, that's 3 plus, more than 15 na PTK, that's would have here the 4 plus. Okay, the next test, we have here the bleeding time. For the bleeding time is a screening test for evaluation of your primary hemostasis. So problem related to your both your blood vessel and your platelets quantity would have here prolong your bleeding time. Okay, procedure for this one, first we have your Duke method. Your Duke method here, process whereby you try to puncture lang ang finger or the earlobe. Usually hindi pinaperform ang earlobe. You can have here your finger na lang na puncture. Procedure for that one, so when you're doing your finger puncture, you puncture that one, wipe off the first drop of the blood. Okay, but then again, as soon as the blood appear here after your puncture, you try to start the timer and try to stop pag nag-stop na ang bleeding. That become your bleeding time. The problem with the Duke here, okay, so ang bleeding nito nakadepende sa number 1, gaano kalalim ang tusok sa'yo. Okay, that will be your depth of your puncture. So, ganyan. Okay, depth of your puncture plus the thickness of the skin. So, pag makapal ang skin, so, di ba? So, hindi siya ganun kaagad-agad magdugo and mag-stop ang bleeding. Same through pag malalim. So, okay siya. Pero pag sobrang babaw ng tusok natin, madali siyang mag-stop ang bleeding. So, hindi siya maging accurate. That's the problem with your Duke na method. So, we have here your modified IV na method here. So, this one tend to standardize the depth of the puncture by application of your pressure cuff. Okay, inflate your BP cuff here at 40 mmHg. Okay, then try to maintain that one. Lagyan mo dito, try to maintain that pressure. Okay, throughout the collection for 40 at 40 mmHg throughout the entire collection process. Maintenance here, the pressure at 40 mmHg would eventually try to standardize the puncture. Okay, na because you're applying pressure, you tend to standardize the depth of the puncture because of that. That is eventually overcoming the problem with your Duke na method. Okay, so ganun din, papapuncture ka lang dito sa forearm and then try to time, okay, when to stop the bleeding. Okay, then we have also here, okay, bleeding time, again, would try to assess your problem with your primary hemostasis, problem related to your blood vessel, platelets, with even your, okay, administration of your aspirin, non-steroid, anti-inflammatory drugs would tend to increase your bleeding time. And finally, we have here the test for your quantitative platelet disorder. We have your platelet count. We could perform here the platelet count manually, directly with your Neubauer your RBC pipette, and your diluting fluid. Indirectly, so just slide estimation, doon ka lang sa slide, magka-count. Or you could also measure here by your automated method with your automated hemanalyzer. For the automated hemanalyzer, for automated method, it classify the platelets between the particle size of 2 to 20 FL. So, kung particle size mo, ganun ang size, 2 to 20 FLs, okay, platelets yan. Yan ang bilang ng machine natin. Okay, then we have here the anticoagulant used here for collection of your blood for your manual. The platelet count, or even for automated, the platelet count is your ETA collected na blood. However, here, your ETA collected blood try to induce platelet satellitism and your platelet clamping. And therefore, as what we have discussed sa HEMA 1, platelet satellitism and platelet clamping tend to induce your pseudo-thrombocytopenia. Bakit ulit? Kasi mapagkamalan niyang WBC ang ating mga clamps ng platelet instead of your platelets. Kaya bababa ang platelet count, tataas ang ating WBC count. Okay, for the remedy of that, just try to recollect your blood. This time, collect in the citrate. And whatever your result, okay, with your platelet count and WBC count, multiply by 1.1. Okay, anyway, then another one, if you are using blood sa skin puncture, compare with the whole blood, kung skin puncture ang gamit natin na source of the blood here, okay, it would have a decreased na platelet count. Okay, the platelet identification under the microscope is not easy to identify because your platelet would have a granular and that one is very small, irregular. It could be mistaken with your debris or even bacteria. Another one, the thing here is your debris, if you try to adjust or find adjustments, is highly refractile ang structure ng mga debris natin. Your platelets, hindi siya refractile. Usually, your platelets, like in your Bower counting chamber, usually ano siya, colorless, greenish, colorless, something like that. And you need to really identify that one your structure as a platelet or not. So, eventually, pag debris ang makount mo, then eventually it would have your erroneous magiging result natin. So, we have here the method for your platelet count. We have here your direct method with the use of your Neubauer counting chamber, RBC pipette ang ginagamit natin, plus your diluting fluid. So, we have here the method for that. So, number one, we have your Riss Ecker. So, this one uses here the following component of the reagent. So, we have here 40% formalin as this preservative, your brilliant crescent blue as a stain. This will help you then identify your platelets. Then we have also here your sodium citrate acting here as the preservative. Guy and leak, on the other hand, the guy and leak, mali ang spelling. Okay, on the other hand, uses here the following component of the reagent. So 40% formaldehyde for the preservative, crystal violet instead of the BCB for the stain, and sodium oxalate instead of sodium citrate to prevent the clumping. And the two here would have uses a diluting fluid that is an isotonic solution. Next, we have here the Brecher and Cronkite. Brecher and Cronkite basically uses here the phase contrast microscope. So, medyo maganda ito, the best here, kung between the three, so itong pinaka-best. So, ang kanyang reagent is 1% ammonium oxalate. Next, we have also your Unipet. This one will have here 1% ammonium oxalate. So, Brecher and Cronkite, Unipet would have here used as a hypotonic solution. Medyo accurate ang Unipet compared with the other three. Pero among the three, okay, Brecher and Cronkite with a phase contrast microscopy. Phase contrast microscopy would be the best na microscope para mag-identify tayo ng platelets for you to easily identify your platelets. Okay, we have here the computation. Okay, for the platelet count here for your Rees-Ecker, Guy and Leak, Brecher and Cronkite. Okay, so procedure for this one, after you try, so with your RBC pipette, aspirate your blood up to your 0.5 mark. Then after that one, try to aspirate up to 101 mark. That gives you a 200 dilution. Okay, then after that one, try to charge your Neubauer counting chamber and try to count the entire 9 square. So, di ba, itong isang ruled area natin, there are 9. Okay, WBC natin dito lang sa 4, di ba? Ang RBC natin dito sa gitna lang. Sa kanya lahat. Entire ruled area. You're going to count for that. Giving you a 9:9 na area correction factor that gives you 1. Your depth correction factor is 10. So, whatever the total number counted here in the 9 square, multiply with your 1 as your area correction factor, 10 with your depth correction factor, and your 200 as your dilution factor, simply multiply by 2,000. Pag unuped ang gamit mo, ito ang kanyang dilution. So, gagamit ka ng 20 microliter na blood. Unuped is siya parang ganun siya. Okay, nalagyan mo lang ng blood dito, meron na siya diluent dito sa loob. So, approximately, ang ma-aspirate nito na blood is 20 microliter or 0.02 ml na blood, and you have your 1.98 ml na ammonium oxalate here that gives you a dilution of 1:100. So, ganun lang. Area correction factor still 1 because I'll be counting it on the 9 squares. Your depth correction factor is still 10 and the dilution factor is 100. So, your factor for that is 1,000. Okay, another one, we have here your indirect method for the platelet count. It's just your slide estimation. This one is di siya ganun ka-accurate magiging result natin. So, we have the method for that. We have damage check here. Gamit siya ng brilliant crystal blue plus your right stain. Then, Folnios, magnesium sulfate plus your right stain. Then, we have your olive. So, all you need to do is just prepare here as smear lang. And then, try to count here under your OIO. So, you'll be counting here 1,000 RBC. So, para ma-obtain ng 1,000 RBC, then you count that one into your 10 OIO field. So, 10 OIO field, ganyan. Okay, ilan ang platelet mo dito, ilan dito, in 10. I-add mo lahat, divide mo sa 1,000, because we are expecting here that in every field nito, there are 100 na RBC. So, 10 times 100 gives you 1,000 RBC. Multiply by the RBC count. You'd be needing here the RBC count for that. Or you're going to have the factor na 20,000. So, that gives you here your platelet count per cubic millimeter or 100,000. Okay, so that's the end for this topic. Okay, thank you.